Alright, so in this video we're going to solve the following problem in Python. Given two strings, write a function to decide if one is a permutation of the other. So before we actually dive in and start writing any code, we need to make sure we understand what this problem is asking, and we need to understand what a permutation of a string is. So a permutation of a string is just any valid reordering of the characters that are within the initial string. So to make that more concrete, let's take a look at an example. Let's consider the string driving. So if we take the string driving and reorder the characters that are within the string, so for instance if we have a string that's drivign, then this is a valid permutation of the string driving, because what we've done is we've permuted or exchanged the n and the g characters. So this is a permutation. However, if we do something like this, where we, let's say do something where we add two d's into this, now this is not a valid permutation of the string driving, because what we've done is we've added a character, an extra d character that's not in the initial driving string. So since we've added another character here, this is not a permutation. And just like if we add some sort of a character, if we remove a character from the string as well, that will also be an invalid permutation. So if we did something like driving, where we remove the d in this case, this is not a permutation. And even if we do something like this, where we're not removing or adding any characters, but we are replacing, in this case, the d of driving with a c. So that is also not a valid permutation of the string driving, because there's no way we can permute or exchange the letters of this string here to arrive at this particular string down here. So this is also not a permutation. So the specification of this problem doesn't necessarily mention whether or not the string is just a single word like this. I guess it could be a sentence or a phrase or anything like that. So, one of the strings that we were given could look something like this. The cow jumps over the moon. With punctuation and everything. So if we're given a string like this, a valid permutation could be the moon jumps over the cow, right? All we've done really is we've just exchanged the word moon and the word cow, and also the placement of the period. So this is a valid permutation of the initial string. But what if we did something like this, where we said the cow jumps over the moon? So is this a permutation of the initial string here? Well, there's a few ways that we can think about that, and there's a few ways that could be the right answer. So if you consider empty spaces to be valid characters, then no, this string is not a valid permutation of this string, because these extra characters were added to this string down here. But the interviewer might not care about that. The interviewer might say, well, extra strings I don't really care about. I only care about non-spaces, right? So in that case, if we don't consider the spaces as a valid character, then this would be a valid permutation of this string here. And in the way that we're going to consider this problem, we are going to consider this as a valid permutation. And this is something that when you're going through an interview, you want to make sure that you clarify these things with the interviewer. You're going to reach these edge cases, and there's nothing in this particular problem to tell you whether or not this is valid or not. So very much up to the interviewer to decide that. So be sure that you clarify these things. Alright, so now let's actually write a function to determine whether or not, given two strings, they are permutations of one another. So let's actually just create some string variables here as tests. We'll use the initial example. So let's say string 1 is equal to driving, and let's say string 2 is equal to what we know to be a permutation of the string driving. Alright, so now let's write our function. And we'll call it isPermutation. It'll take two arguments, string 1 and string 2. And we're going to do a few things here. So the first thing that we're going to do is, if we're given something like this, where we know this is a valid permutation of this thing, this initial string here, we know that we should probably remove the spaces because the spaces are characters that we just don't care about. So as sort of a pre-processing measure on our initial point of our function here, what we're going to do is we're going to remove any of the spaces that are present in the strings that were passed. So let's say string 1 is equal to string 1 dot replace any space with just nothing, and we'll do the same thing with string 2 as well. So this will just get rid of all the spaces in the string, and again, we don't care about empty spaces for this particular flavor of the problem. So what's another thing that we can do just right off the bat to help us out here? So if you consider this example here, this driving example, consider these two non-permutations. So we know right off the bat it's very easy to see that these are not permutations, and one way we can see that is that there's an extra character here and there's a lack of a character here. So in other words, the length of driving is not equal to the length of this one nor this one. Now that doesn't necessarily take care of this case here where the lengths are the same, but we'll take care of that later. So the initial thing that we can take care of right off the bat is if the lengths of string 1 or string 2 are not equal, we know that they can't be permutations of each other. So let's just write that down into our function. If the length of string 1 is not equal to the length of string 2, then we'll just return false right off the bat. Okay, so now we've got this, and now what we want to do is we want to go through the string that we're given and determine if the other string, string 2, is a permutation of that initial string. So if this if condition's hit, we know that the strings are not the same size and the function returns false. So if we escape that if condition, if it doesn't hit, then we know that the length of string 1 and string 2 are equal. So what we can do is we can loop through one of the two strings, and we can check whether or not the character is present in the second string. So let me walk through an example of that. So let's say we're looping through the string driving. And what we're going to do is we're going to check whether or not the character is present in the second string. Let's say the second string is this string right here. So let's loop through D. D is present there. What we'll do is we'll remove that character from the second string. Okay, we'll move on. We hit R. R is present. We remove that. I, V, I, and G, they're all present in here, and they get removed. So at the end of the day, once we've processed and looped through all of the characters of this string, we're going to remove the characters from the second string. And what we can do is we can check whether or not the length of the second string is empty, because if it is, we know it's a permutation. So let's, for instance, consider this other string, which we know not to be a permutation, considering the same method that we described above. So if we loop through, we hit a D, we got that. We hit an R, we remove that. Hit an I, get that. And we'll continue on until all of these characters are removed. But at the end of our loop here, we'll still have this D, because there was an extra D here. So we'll know that the length of this second string is not 0, and that will tell us that this is not a permutation of the initial string. So let me just undo that. So we have our examples there. And let's implement what we just described above. So since at this point we know the lengths of the strings are the same, let's loop through string 1. So for the character in string 1, we'll say if that character in string 1 is in string 2, what we're going to do is we're going to remove it. So we're going to say string 2 is equal to string 2 dot replace C with nothing. So as we proceed here in this loop, as we loop through string 1, if the C, the character that we see in string 1, is present in string 2, we're going to replace that character in string 2 with nothing, just as we did as we were considering the example above. And then our final condition is we'll return whether the length of string 2 is equal to 0. So if string 2 is equal to 0, we know that it is a permutation. So let's just take this function for a test here, and let's try them out on string 1 and string 2. So let's print is permutation for string 1 and string 2. So this should return true. So let me go over here to my terminal. If I do an ls, we see the script that I'm writing to over here on the right hand side. So I'm going to type in Python is permutation, and let's see, I have some extra stuff down here. Let me just get rid of that. Let's see, that was from before. So let me try that again. Let me clear the screen, and we get true. So this is indeed a permutation of driving. Now, just to make sure that we get something, it acts properly on these other examples as well, let's replace this with the other example that we considered, where we replace that with an extra D. Save that, run it, we should get false. Indeed we do. And let's just try this one. And we know this is also not a permutation of driving either. So let's save that, run it, and we're getting false.